So guys, now we will move to the next topic further on the ignition burner or the pilot burner. So don't get confused with the name. If you see somewhere in this manual written as ignition burner, basically it is the pilot burner which is going to give you first ignition. Okay, so from here ignition will take place. So this pilot burner will have electrode, okay, a set of electrodes, two electrodes for producing spark. Now I'll come to that. Okay, so model number is this. Now let us see, this is nozzle tip. So nozzle tip, basically if I draw for you a pilot burner, it will look like this. We'll have a tip on this for the atomization, and you will have on the top of it, you will have two electrodes like this to create a spark. Okay.
To every marine engineer out there, from junior engineer to chief engineer and electrical officer, we all know that earning respect on ship is very important. We all know fast promotions are very important, and we all know that इज्जत कमानी है, promotion चाहिए तो काम आना चाहिए, तो जूते पड़ते हैं, गालियां पड़ती हैं, and for that you need a good mentor. Sometimes we keep finding those mentors on board ship, अगर नहीं मिल रहे तो MNDFLIX है ना, Merchant Navy Decoded has launched a subscription model where you can find more than 30 plus courses with respect to your rank, helping you earn respect on ship. Please enroll on these free trial videos, watch these videos as per rank, and then decide whether you want to invest or not, with a very good flexible payment plan as well. Jai Hind, Jai Bharat, Jai Mata.
Now the question. This distance. So first let's discuss about the electrodes over here. Electrodes number 52. So this distance between the electrodes is said to be around 2 to 3 mm gap. When this distance is disturbed, if you increase this distance or if you reduce also this distance, then also there is a chance that the flame will not take place. Spark will not take place and the flame will not take. Spark even will take place maybe, but the flame will not be there. The flame will sense the misfire alarm, because this spark, and then there has to be atomization here, so that this spark can catch fire in this atomized fuel, right? So this gap has to be 2 to 3 mm. And what is the logic behind this 2 to 3 mm? Let us understand today. So you see, air is like an insulating material. Air is an insulating material. But any insulating material has got a breakdown potential where it will allow the voltage to pass, or it will be ionized. Okay, so for air, in case of air, it is around 3 kilovolt. Okay, so if you supply voltage of 3000 volt across two terminals of the air, it will get ionized. Okay, spark will be produced. Now in our case, you see, if you keep the distance very less, what will happen? If fuel is being sent like this, say through the nozzle tip, if the fuel is sent like this, and if you are keeping the position of the electrodes very near to each other, even if the spark is produced, the flame, the fuel which is atomized, say 60-degree angle means it is angle of the spray cone angle. What does this mean? Now let me draw a nozzle for you. So this is your nozzle, right? This is your nozzle. So if this nozzle is having 60-degree spray cone, so that means when it will spray the atomized fuel, it will be making an angle of 60 degree. You will find 55 degrees also. So that means this is how the pattern of spray will be from this nozzle tip. Now if you place the electrodes very near to each other, there will be so much of the fuel, density of fuel will be so high that this spark will get extinguished. So you will not get flame. That is why what you do is you keep the position of electrodes at such the distance is here approximately 2 to 3 mm, where the propagating cone or the velocity of this atomized fuel is not that much. The spray is in the fine mist form and the spark is also present, so flame will be stable here. That is why you need 2 to 3 mm gap. Now for this, how much voltage? So let us see, the ignition transformer is there, which is a step up transformer. Since we know that our vessel is producing 440 volt, you need to step up this to get at least 2 into 5000. That means there are 2 electrodes, one each is having 5000 volts supply. So total of 10,000 volt is generated over here. Okay, 2 into 5000. This is the power rating for the ignition transformer, 200 VA. That is the power rating for ignition transformer. Okay, now let us understand. So you need 10,000 volt or 10 kV, that is coming under the high voltage, 10,000 volt or 10 kV. But why do you need 10 kV when only 3 kV is sufficient to create a spark, to ionize the air? Okay, so air's dielectric strength is 3 kV. Dielectric strength is 3 kV. You need to ionize the air. For you that you need any potential which is above 3 kV. But we have now understood that with 1 mm gap, if you reduce the gap or only you supply 3 kV, reduce the gap, the flame will be extinguished because the flow of the oil or the atomized oil is too much there. So you need a little bit more separation over there. When you give it like this, when you keep it like this, the more in this position, the spark is little bit at this distance of spark increases. Also the propagating atomized fuel is also stable there. The flow and the velocity is not that much that it will be easily be able to catch fire. Okay, now so the formula for this will be the distance multiplied by the ionization potential or the dielectric strength of air. So distance, if you keep it as say 2 to 3 mm, we keep it as 3 mm. Say, okay, 3 mm multiplied by 3 kV, it comes out to be around 9000. So you see there is 9000 voltage required. So this is one of the questions asked in electrical in MMD exams also. Why do you need 10,000 volt to create a spark? What is the funda behind this? So you see 9000 volt is at least required to create the ionization, to create the spark and then establish a stable pilot flame over here. So to be on the safe side, this is 9000 volt required. What we supply is 10,000. Same concept lies with the boiler pilot burner also. That is why we require 10,000, 11,000 volt in the boiler pilot burner electrode sparking. Okay, that is we understand, right? And also the spray cone angle. So if your nozzle is like this, the nozzle will spray the oil in form of a cone like this, and the angle this cone forms is called the nozzle tip angle, spray cone angle. You will have different kind of spray cone angles for different nozzle tips also. You can have 55 degrees also, 60 degrees also, like this, 62 degrees also. And 3 gallon per hour is the capacity. If you see the gallon per hour, 1 gallon is approximately 3.785 liters of oil. So 3 gallons is equal to 11.36. So approximately if your pilot burner tip is pilot burner is consuming 11.36 liters per hour of diesel oil. Okay. So this is the study about the pilot burner, a very important concept about this spray cone angle. And so different nozzles, you will see a different spray cone angle, and there is a relevance of why do you use this spray cone angle like this. Okay, first thing is this, and second thing is the potential. Why do you need 10 kV of potential to create a spark when only 3 kV is sufficient, and what is the dielectric of air? Okay, that you need to overcome. This is the concept behind the ignition burner and the pilot burner. A very detailed video of this will also be coming in this section, where we will be discussing what will happen if you alter the position of the electrode tips, or if you alter the position of the nozzle also. So that will be separately covered. Okay, wait for that section. Okay, thank you guys. Next one we will be discussing about the second burner unit.